Okay, so for today we're going to be working with circles, but let me explain something about circles first. Okay, so let's see. Let's assume that what I'm about to draw, let's assume that's a circle. And on a circle, we have a radius, right? The radius is from the center to the edge of the circle. We're going to call the radius. Now, the radius, I can just grab a string, right? I can grab a rule, but in this case, I could grab a string and I could measure how big is the radius. Based on that measurement, I can find out what's the distance around the circle. The distance around the circle we're going to call circumference. We're going to say what's the distance around the circle based on the radius. So if again, I grab a string, I measure how big is my radius, and I put it right around my circle, it will come out to be about there. So let's just say 1 radius. And then I do it again. It's gonna be about, let me mark it, should be about there. It's gonna be 2 radius. And it will be about there. 3 radius. 4 radius. Like I said, I measured with my string. Oh, I can go around 5 radius. And then this one, it's gonna be about there. 6 radius. And there's a little bit more. You guys see this gap. So matter of fact is about 0.28 radius. Okay. Now this thing later on in future classes, you guys are gonna call this radians. Okay. You remember how we use a calculator? I said keep it on degrees, not radians. This is what he meant. And then I even mentioned 6.28 radians is the whole circle. Remember how I mentioned that a few days ago? All right. So we're gonna say the circumference, the distance around the circle is going to be about 6.28 radians. Okay, I'm going to say times the radius. Now, you guys remembered, and this is about, remember how we know a number pi? If I ask you for pi, probably most of you guys will say it's about 3.14. Okay, 6.28 related to 3.14. Isn't that 2 times pi? So I'm going to say the circumference is going to be 2 times pi times the radius. Now, some people just like to call it 2 times radius times pi. They just move the order to have pi at the end. You guys probably have seen this as diameter times pi, right? You guys probably have seen diameter times pi. Now, this is how the circumference came along. They came and they measured with the radius, and they said it happens to be 2 times radius times pi, or diameter pi, however you guys want to call it. But then we can figure out what the area of a circle is. Let me show you guys how it got derived. So let's assume this is a circle. Now, the interesting part of a circle, like I said, let's call that a circle. The interesting part of a circle is that it can be broken down into triangles. So a person, you could come over from the center, you could cut a triangle there, and there, and there, and there, and there. Like you can cut it into a bunch of triangles. The smallest width of the triangle you can find, the better approximate you're going to get to the answer. But then somebody did that and they said, well, if I get my first triangle here, it's about there. And then my second triangle, I put it up here and it's going to be about there. And then the third one, and then the fourth one, and so on, so forth. So somebody came and put all the triangles together. Interesting is that this, I'm just going to put those triangles, but let's say we put them all together. Interesting part is this ends up looking like a rectangle. All right now it looks like a parallelogram, but like I said, the thinnest you go on your triangle, so that means that let's say your circle, you cut it in as many pieces as possible. as many as possible. So the more, the better. That's going to approximate the area of a rectangle. That's going to be exactly the area of a rectangle. Interesting part, though, is this short side is the rectangle, is the radius. Remember how we saw a figure like that? The short side is the radius. Now, the other side, the long side, is the circumference. The only part, though, is that part of my circumference is there and part of it is here. Okay, you see how I had my circumference around it. Interesting part is that I have the half of the circumference on each side. I know my circumference is 2 times radius times pi. Let me remind you guys. My circumference is 2 times radius times pi. But each side of my rectangle is half of that. So shouldn't it just be radius times pi? Because it's the half of the circumference. Now I know how to get the area of a rectangle. I multiply the two sides that make the 90-degree angle. Eventually, this will be a 90-degree angle. Like I said, the thinnest you can go on your slices, that's going to be a 90-degree angle. So I'm just going to go radius, which is the small side, times radius times pi, which is the long side, which we're going to abbreviate this as radius squared pi. Radius squared means I'm going to multiply the radius twice. Pretty cool. That's how the formula for the area of a circle came along. Now you guys know the area of a circle, you guys know the circumference of a circle. We're going to use both ideas later on in this lecture. So let's take a look. Here it says find the area of each. They look like circles. 15 and 16 look like circles. Use 3.14 for the value of pi and round your answer to the nearest tenth. Okay. We just found out right now that area of a circle was radius squared times pi. Radius squared means radius times radius, right? I'm going to multiply the radius twice. In question number 15, the radius is given, right? It's a 2. So I'm just going to go 2 times 2. I had to multiply the radius by itself, radius squared. Then I had to multiply this by pi. But my instructions said use 3.14 for pi. So instead of the number pi, let me write 3.14. So I'm just going to go 2 times 3.14. According to my calculator, I get 12.56. But I have to round this to the nearest tenth. So again, like I've been doing, this 6 is big enough, so it pushes the 5 over. So I'm going to call this 12.6. Pretty cool. So just having the radius, I can find out what's the area of a circle. Now, question number 16, I don't quite have the radius. I have the diameter. You notice how my measurement in there crosses the entire circle. The radius is half of that. Now, some of you might be like, Mr. Leonzo, I know how to get the half of an even number, right? I know how to get the half of 6. I know how to get the half of 8 or 10. But decimals, how do I get the half of a decimal? Or sometimes, how do you get the half of an odd number? Like if I ask you, what's the half of 5? Well, to get the half, just divide it by 2. So I'm just going to go 13.8, which is the whole diameter. Let me divide this by 2. And I'm dividing that diameter by half. I'm dividing it by 2 because I just need the radius. The radius, if you notice, is from the center to the edge. The whole diameter is 13.8, so the radius will be 6.9. I just need the radius because my formula says radius squared, right? Radius times radius. So now that I have the radius, I can figure this out. I'm just going to go 6.9 times 6.9 because I have to go radius squared times 3.14, right? We have to multiply this by the pi, but we're going to use 3.14 for a pi. According to my calculator, I have 149.49. The second decimal number pushes the previous number up, so my answer will be 149.49. 0.5. Pretty cool, okay? So now we know how the area was created. Now we know how to use this. So find the area of circles, whether I have the radius given or the diameter given, I'm good. But now I'm going to ask you guys to find the area of each sector. The sector means I don't want the area of the whole circle. I just want the area of part of it. Now, there is a proportion, okay? What we're going to be doing, the interesting part is area of the sector. I'm going to write this thing down. The area of sector over the area of the circle. Okay, so it's a fraction. The area of the sector divided by the area of the circle is going to be the same thing as angle of sector over the angle of the entire circle. Okay. We didn't know circles had angles, but yeah, they do, 360 degrees. So let's take a look. Let me replace the values that I know. The area of the sector, I have no idea what it is, right? That's what I'm finding, as I'm solving. So I'm just going to say X, because I have no idea what it is. The area of the circle, okay. For the circle, I need to find out the area, and I know because the radius is 12, I know I'm going to go 12 times 12 times pi. For right now, let me just call it pi. I don't want to deal with that many decimals. So 12 times 12 times pi. Now, some of you might come and say, can I just call it 144 pi? And I'll say, okay, sure, you did the 12 times 12, right? Radius squared pi. Good. And this is going to be equal to the angle of the sector. Okay, so this sector I see is 90 degrees. So I'm just going to call this 90 degrees over the area of the entire circle, which is 360. Okay, so now I want to leave x by itself. I have a fraction. So let me make this fraction on the right a little bit bigger. I want to have x by itself, so let me multiply both sides by 144 pi. So let me multiply it up here by 144 pi, because that way these cancels out, so I get the x by itself. Now notice on the fraction, notice how I wrote the 144 pi on the top. So I'm just going to grab my calculator. Let me type this in really quick. Let me show you guys what I'm doing. I'm just going to go 90 times 144 times 3.14, because that's what I'm using for pi, divided by 360. So 90 times 144 times pi divided by 360. Okay. According to my calculator, I get 113.04. Let me come back to my work. So 113.04. My second decimal number is too small, so I'm just going to ignore this. So 113.0. Okay, or 113, right? The 0.0, we can ignore this. Okay, not that bad. Let's take a look at question number 18. The area of the sector, I have no idea what it is. That's what I'm solving, so I'm going to call it X. The area of the circle. Okay, so my circle has a radius of 5. So I'm just going to say my circle is 25 times pi. My 25 because I went radius squared, right? We could have done 5 times 5 times pi, but I just did 25 pi, right? We know what 5 times 5 is. Now, the area of the sector, in this case, is 150, and then over the whole circle. Okay, let me extend this fraction. Let me multiply both sides by 25 pi. I'm not going to show you guys my calculator, but I'm pretty sure you guys can see what I'm going to do. I'm going to go 150 times 25 times 3.14. That's everything I have on top of the fraction. Divide this by 360. According to my calculator, I get 32.70. Second decimal place is too small, so it's 32.7. Cool, that's not that bad. So we can do the area of the sector, the area of a circle. But now let me ask you, what's the length of each arc? So I want to know this distance outside of the arc. I don't want to know the area. Remember for question 17 and 18, basically I was asking, what's the area? What's the space inside of the sector? Now the length of the arc is basically how big is this. Okay, so this we're going to use a formula as well, a proportion. And I'm going to say the arc length basically what we're solving, divided by the length around the circle. Now that one, I'm just going to call it circumference. That's the area around the circle. Remember how we measured earlier with radians that it was 2 times radius times pi, so it's not that bad. So the arc length divided by circumference, and remember circumference is the fancy way of saying that the length around the circle. It's equal to, we're going to call this sectored angle or angle of sectored. Sector is basically part of a circle divided by angle of circle. And again, the degrees around the circle is 360. So it's really not the angle of the circle, but I'm going to call it angle of circle so it makes sense. Basically, the degrees around the circle. Okay. So the arc length, I have no idea what it is, right? We're solving for that. So let me just call it x. The circumference, the distance around the circle. Let me remind you where we did that. Remember, we said that the circumference was going to be 2 times the radius times pi. Okay, so now that I have that, I reminded you what we did. So 2 times the radius. Look at the radius is 7. So I can write 2. So let me write this to begin with. I could just write 2 times 7 times pi. Or you can be like, so Lorenzo, I know what 2 times 7 is. I just want to write the least amount of numbers as possible so I don't get too confused. So, okay, so sure, let's call this 14 pi. Okay, so it's x. So the arc length divided by 14 pi is equal to, the angle of the sector is 45 degrees. And the angles around the circle, I call it angle of circles, so we keep the same wording, but it's really the degrees around the circle. It's always 360. Okay, so I gotta get x by itself. Let me multiply both sides by 14 pi. Multiplication of fraction, I write it on top. That way the 14 times the pi cancels out. And there. I'm just gonna grab my calculator. I'm gonna go 45 times 14 times 3.14. All of this divided by 360. And it's gonna give me 5.49. My instruction said to run it to the nearest tenth. Okay, so I had to run it to 1 decimal place. This 9 pushes this 4 over, so 5.5. Lastly, let's take a look at number 20. The arc length, have no idea what it is. That's what I'm solving. The circumference, okay. The radius is 13. You can see the radius 13. So I'm going to say the circumference is going to be 26 pi. I just went radius times 2. This is going to be equal. The angle of the sector, which is 90, and then the degrees around the circle, it's 360. Let me multiply both sides by 26 pi. Remember here I had to make this longer. So I'm just going to go x equals 90 times 26 times 3.14 divided by 360. And it gives me 20.41. That 1 is too small, so I'm just going to ignore this. So 20.4. Nice. Let me show you what we did.